Hello again, Algebra 2 people. So this section, 6.6, is about solving your exponential and log equations. And so the one thing we're going to focus on is trying to identify types of equations. And by doing that, then associate a strategy with each type. So we're going to start off with exponential equations. There are two strategies. One strategy is if you can rewrite the two exponentials with the same base. If you can write them with the same base, then you can just ignore the base because you've already set those equal and focus on solving the exponents. All right, so let's do a few examples and see how that works. And you've already done this actually when you had to evaluate logs earlier and we wrote them as exponentials. So now it's coming to you as an exponential. So we have 5 to the x equals 25. Well, 25 can be rewritten as 5 squared. By doing that, I can cancel my 5's, and we know our answer will be x equals 2. There's a nice simple example. Now you won't always see the base that the two share, so sometimes you have to think about it. So we know that 4 and 8 are related, but not exponentially. The base that they share is actually a base of 2. So I can rewrite 4 as 2 squared, and the x just kind of carries along. 8 is going to be rewritten as 2 cubed, and the rest of these terms, since there's more than one, go in parentheses. Now that I have my two bases the same, they can cancel, and I'm just solving 2x equals, and I'm going to distribute that 3, negative 3x plus 3. And now to solve that, we will add 3x to both sides, and then we can divide both sides by 5, and that would be your answer. Okay? If you happen to have one side involves a fraction, most likely your exponent is then going to be negative. So we have 3 to the x equals 27 is 3 cubed, but since it's 1 over 27, this is 3 to the negative 3. Same thing, bases are the same, I can cancel them, and our answer is x equals negative 3. And then we have 100 to the x equals 1/10 to the x minus 3. They share a base of 10. So 100 is 10 to the 2, and then the x carries along. 1/10 is 10 to the negative 1, then in parentheses, x minus 3. And from there, we can now cancel our base, and we set 2x equal, after I distribute this, we have negative x plus 3. So adding the x to both sides, we have 3x equals 3, and x equals 1. If you get a nice answer like that, a nice integer, sometimes you can actually go plug it back in and verify that your answer is in fact correct. Okay, that's if you can write them with the same base as an exponential. That is not always going to be possible. So here, if it is not the same base, then our strategy is two-pronged, all right? First step is you rewrite it as a logarithm, and then the second step will be to use your change of base formula so that you can get a decimal answer for it, or to leave it in exact form from the change of base. So we see here 2 to the x equals 7. And you look at it and be like, okay, I can't write 7 as a power of 2, and you have nothing else to do. So when it's sort of like, I have no idea what to do, if it's exponential, write it as a log. So as a log, this is going to be, we write the word log. Remember it all about the base. You start at the base, always go to the other side of the equal sign. So base 2 of 7 equals x. That is the whole purpose of logarithms, is to solve for an unknown exponent. And here we go, we've isolated our x. But what is log base 2 of 7? We can't plug that into our calculator because it only understands base 10 or base e. So we are going to apply our change of base formula, Remember, that means you write log over log. I'm going to write this as a common log, base 10, so I don't have to write the 10, that's our default. Subscript goes downstairs, 7 goes upstairs. As far as I'm concerned, you're done. That's a legitimate answer. It's an exact answer, but the idea is you could go to your calculator and plug that in, and you'd get 2.807. Okay? So exponentials, two strategies. Either you can write it with the same base, and then you can just cancel out that same base, solve for your exponents. Or if you can't write them with the same base, you write it as a log, and then turn it into change of base. Okay, now let's look at our log problems. If we're solving log problems, you also have two strategies. I call these strategies a balanced log or unbalanced. Now, to start with, you're only ever allowed one log on one side of an equal sign. So you could have a log equals a log, or you can have a log equals a number. You may not have more than one log. That's when you would use your condensing properties to make it into one log. So if it's balanced, these ones are kind of like the same base problems. If I have a log equals a log, and yes, they will always have the same base for our purposes, then you can just cancel out the log and set the two arguments equal to each other. So in this first example, example 4, notice ln 4x minus 7 equals natural log x plus 5. We can just cancel those out, and we're just solving 4x minus 7 equals x plus 5. Subtract x from both sides, add 7 to both sides, and we get an answer, x equals 4. Now with logs, you have one little cautionary tale because you may not have a negative argument. So once you solve, you want to just do a quick check. If I were to plug 4 back in, would it keep my argument positive? In this case, it does. So always check your solutions keep the original argument positive. Otherwise, you have an extraneous solution which you just eliminate. You saw this in geometry when you did quadratics to solve for, say, the side of a parallelogram. If one answer was negative, you threw it out because you can't have a negative side to a parallelogram. Okay, let's try example C. Now, it looks like we have 1 log equals 1 log, but we have this coefficient here. So what we have to do is get rid of it. I can't divide to the other side because then I have a coefficient on the other side. So we're going to use our power rule to move it up on top. So we have log base 8 of x equals log base 8, 81. Now I have a balanced log equals a log, so these can cancel. Whoops, I forgot my x to the 4th there, sorry. So we have x to the 4th equals 81. And so we're going to take the 4th root of both sides. And since it is an even power and an even root, our answer comes out as plus 3 or negative 3. So both 3 to the 4th and negative 3 to the 4th would give me 81. But remember, we have to now check. If I take 3 and negative 3 and look at my original argument, a negative 3 would give me a negative argument. So we throw it out, and x equals 3 is our only answer. All right, so that's one strategy when you have balanced logs. 1 log equals 1 log, no coefficients, nothing else going on. The other strategy is when it's unbalanced. You have 1 log equals 1 number, and that strategy then is write it as an exponential. Just like in the other example, we had an exponential, we wrote it as a log. So in this problem, example B, first thing I'm going to do is isolate the log on one side. So I'm going to add 17 to the other side. So I have log base 2 of 5x equals 20. And we look at that and it's like, okay, what do I do? So that's whenever you're like, what do I do? Write it as the other. So if it's a log, write it as an exponential. So we start at the base, go to the other side of the equal sign, 2 to the 20th equals 5x. And our goal is to solve for x, so we're going to divide both sides by 5. And as far as I'm concerned, you're done, because 2 to the 20th is some huge number, so might as well leave it in exact form, and you also don't need a calculator. All right, so when confronted with a log, unbalanced, log on one side, number on the other, write it as an exponential once you isolate your log. So this one is already isolated. We have 1 log equals 1 number, so we're going to write it as an exponential. So we start off with 8 to the 2/3 equals x squared minus 5. And if you remember from chapter 5, the bottom number represents the cubed root of 8. So the cubed root of 8 is 2, and 2 squared is 4. So we have 4 equals x squared minus 5. So then adding 5 to both sides gives me x squared equals 9. Take the square root. So x equals, again, plus or minus 3. And we want to plug it back in just to double check. Now in this case, x squared doesn't matter whether I plug in a positive or negative, because it will make whatever I plug in positive, so both positive and negative 3 work. So a negative number answer is okay, so long as it keeps the argument positive. Now, to continue with our solving logs, balanced, unbalanced, like I said, you can only have 1 log on a side and 1 number on a side, or 1 log and 1 log. So when you find that you have 2 logs here, we have to do our condensing property. So remember, subtraction goes with division. So I'm going to condense 2 logs into 1. So 2x will be in the numerator divided by x minus 5, and that will now equal 2. So there's our log, and we write it as an exponential. So remember that if you don't see any base written, it's understood to be a base 10. So we'll write it in there just to emphasize what we're doing. So we're going to write this as an exponential. So you start at the base, go to the other side, and then set it equal to the argument. So we have 10 squared equals 2x divided by x minus 5. So what we have here really is a proportion, because I can put 10 squared over 1. So I'm going to cross multiply. So we have 2x equals 100 times x minus 5. So that gives me 2x equals 100x minus 500. And I'm going to move my 500 to this side, add it to this side, subtract 2x from the other side. I like to keep things positive whenever possible. And we do want to solve for x, so we're going to divide both sides by 98. And that's our answer, 500 divided by 98. I could go through and reduce it. What is this? If I take half of each, that would be 250, and this would be 49. And as far as I'm concerned, we're done. Okay? So remember, if you have more than 1 log on a side, you're going to have to use your condensing properties. And in this case, subtraction goes with division, so we had to divide our 2 arguments. Okay, the last thing we're going to do is solving inequalities. And the key to solving an inequality is don't move your log or your exponential terms around, because you might change the inequality. We are going to be taking advantage of those properties where if the base of your log is the same as the base of the exponent, remember they cancel each other out. Same thing if I have an exponent, the base of the exponent is the same as the base of the log, they undo each other because they are inversely related, and you get back x. So we're going to create so that we have the base of an exponential is the same as the base of a log. So in this first problem, 3 to the x is less than 20. I'm going to write it down here with a little bit of space. So what I'm going to do is I'm going to write to both sides, so I maintain the inequality. Since the base of my exponent is 3, I need a log of base 3. So I'm going to multiply both sides, log base 3. This now cancels, so x drops down. And we have log base 3 of 20, which again, what is that? We don't know. If we wanted a decimal, what we would have to do is use our change of base formula. So I'm going to write log over log, turn it into a common log. The subscript goes downstairs, 20 goes upstairs. And that would be our final answer. Okay, so on this next one, you do want to move any kind of just constant terms. So I'm going to subtract 9 from both sides. So I have log x less than or equal to 45 minus 9, which is 36. So again, we don't see any base, but it is a base of 10. So I have a log with a base of 10. What I want is an exponent with a base of 10. So these two terms are going to become our exponents, and our base is going to become 10. So I'm going to raise both sides from a base of 10. And now this will cancel. So I have x less than or equal 10 to the 36. And we're not even going to multiply that out. That's just a lot of zeros. And we're done. Okay, last one. Let's isolate our natural log. So I'm going to add 1 to both sides. So I have 2 natural log of x greater than 5. Now at this stage you might think we have two things we could do with that coefficient of 2. I could use my power rule to make x become x squared, or because it's a number on the other side, I could divide by 2. And that's going to be my choice because solving for x is easier than solving for x squared. So I'm going to go ahead and divide both sides by 2 so that I'm left with natural log of x is greater than 5/2. So remember, natural log has a base of e. I'll just write it in here to emphasize it. So what we want is an exponential with a base of e. So I'm going to raise both sides from a base of e so that these will cancel. So I just have x is greater than e to the 5/2. And we're done. Okay, so I hope that helps. That would be solving log problems and inequalities and exponentials.